All right, so now I'm going to look at your screen.
You're gonna introduce, like, start the
Full
stream,
screen.
I presume.
Yeah. And then we're looking for chat. I wish it was easier to get the chat. I have to like go through the whole to like find where it is streaming. Pop it up. All right. How about chat? Chat. Close that. Find you again. Okay, cool. All right, so we are continuing where we left off in the previous stream, where we were talking about type systems, and we are now going to try to apply what we learned through type systems into something where we can actually see something happening, because programming is only as useful as it getting something actually done. It's a tool. As much as we like to talk about cool stuff with code, we actually want to do something with it at the end of the day. So we're going to see how Elm can help us write websites and try to heal humanity of its scarring with JavaScript. So without further ado, I will hand it off.
Yes. So let's start with a short recap on what we've done last time. So we've seen types. They look something like this. This is a function that takes two integers as arguments and gives an integer as a result. Other things could be, for example, something like bool. Another thing we've seen is a slightly changed way of applying functions. For example, if we take a plus function, you would normally write something like two plus four and five. In notation, for functional notation, we don't use these brackets. We just say plus followed by like a space, an argument, space. In this case, the other hand goes in brackets. So with, again, spaces. So these two expressions are expressing the same thing here using what you might be familiar with from JavaScript. And this is a more functional style where you do not explicitly apply a function with arguments. You just use the space character for that. And that also goes back to the fact that what we have seen last time, that technically all functions have just one argument and then can produce another function, which in turn can take more arguments. And the final thing that will be important, and we'll be talking about this quite a lot later, is that you can make your own data types. So you can say something like, you can have a data type like Monday or Tuesday or Wednesday, Friday, and then you can just say, hey, let's call this type weekday, and this way we can make our own types. Um, is this all familiar still?
Yep.
Okay.
Been trying to code in it, but I still have some questions, so we'll see where we go today. See if we can
Yeah,
get them answered.
we'll get to that in the practicum. But first, let's have a more high-level introduction to Elm, thinking about none of this, and then we'll get to it as we get to it. I should have a button here. There we go. So, an introduction to Elm. So Elm is a functional programming language designed for making web apps or web applications. So it is a functional language to make web apps. To exemplify this, you would normally use something like JavaScript. And for using JavaScript, you can have a stack that looks a bit like this. So you have a package manager, and you can have something like React, the TypeScript, have types immutable to keep things immutable, etc.
This is insane. Like you said, you haven't done much web development, but it is like insane because it's like, yes, this is one person's attempt at making one stack, but depending on like what time of day it is or where you are in the world, like these things change so rapidly. So I know you said you don't have much experience, but like it is so funny because it's like you are right. Like this is totally something that you could use, but it's like it changes so often.
Yeah. And the nice thing here is that this kind of stack is, if you were to do this in Elm, the Elm stack would look like this. You just use Elm. A package manager.
Oh,
this whole thing is integrated. The tooling in Elm is lovely.
So good.
And Elm has a really strong philosophy in building. It does some things differently than you would do from JavaScript, and it has some really strong opinions. The first thing is it really, really tries to make compilers your assistant. So instead of a compiler being like, you made a mistake, it will try to give you hints or point you to documentation, which can be really lovely. It is also, in that sense, it doesn't really blame the user. So if you make a mistake, Elm has trouble interpreting what you meant. It's not that you did something dumb or something stupid. On the other hand, it has no trust in the users. And you might be familiar from this from a cybersecurity perspective, where trusting the user is something, or trusting developer is something really bad. You want to make sure that your users, even if they make mistakes, they should be like there should be safeguards in place. There is a reason we place railings if we don't want people to fall off platforms, even though most people will never use those railings. In that same sense, Elm will not let you do weird hacky stuff, bit hacks. There are some escape hatches to get out of this really safe environment, but in general, it really tries to prevent you doing dumb stuff or using really complicated syntax. Some people really don't like this, but it does lead to a great amount of standardization. Elm really likes to standardize how you write Elm code and how you do certain things in Elm. Of course, there will be different packages that do the same thing in a slightly different way, but in general, if you need to express something at the lower level, you will do it the same way. Elm prides itself on that all Elm apps look alike. A great example here is the compiler or the formatter, sorry, and Elm has no configuration options. So on the one hand, it might place commas in a weird way that you don't like. On the other hand, if you get used to that, you are now used to the layout that every other Elm programmer uses.
Right.
Which can be super convenient. And as any language, it has some pros and cons. And I would like to start with the cons. So one of the bad parts of using Elm is that Elm tends to have a lot of boilerplate. There's a lot of stuff where languages like Haskell, who are also functional, have really elegant syntax to do this. Because Elm wants to do this standardization part, you will sometimes have to write more different instances of the same function, or write a similar function for something slightly different. You might have to write it out. because it doesn't like doing things like classes and such. That leads to a lot of boilerplate, and it sort of embraces that, as in a lot of languages tend to find this a really bad thing, but Elm sort of accepts it to retain some of the other things that are good about Elm. Another bad thing is everything that's not web dev. Elm is really focused on web development. Everything that is not, it's just not the right tool. You would be better off using a Haskell, an OCaml, anything else. It doesn't do advanced syntax. I sort of touched on that. It tries to make sure that you only have one way to express something. That does mean that if you want to, for example, define your own syntax or do advanced things, Elm is not the tool for you. There are some things you can do by this sheer fact of it being a functional language, but it's not the best. Elm also had some breaking changes where a newer version of Elm actually reduced the syntax, and they don't like making these breaking changes, but they will do them if they think that it will improve the general state of code or of the compiler. And on the one hand, this really keeps the compiler clean. On the other hand, this can be really annoying if Elm comes with an update and you need one of these new features that you've been looking forward to, and it turns out you need to fix all your code first. Although I must say, fixing code in Elm is not as bad as in most other languages. But of course, you might be the exception to this rule. Another thing is that the user base is not that big. Elm was released in 2012, where it since built up some community, but there are still some things that it simply doesn't support because, well, who uses Elm? The user base is quite small, although if I recall correctly, it's growing. I might be wrong on that. But I certainly hope it's growing because I think it's a really nice way to do stuff. Also, Elm makes package development difficult, mainly because it has some quality requirements, especially for documentation in order to get on the standard package manager. And otherwise, Elm is not scared of saying, well, just host it as a GitHub repository then, and then people can download it themselves. There are some upsides to this, that it keeps the quality high, but this can be annoying. Another thing is you get no control over the JavaScript it generates. So you cannot do, oh, I am using this specific browser on this specific phone and I need to formulate this statement a bit differently. You will have to approach that by maybe making your own fork of the packages or whatever. There's
That's
no building way in Elm to mess with this. So for some very advanced use cases, Elm also might not be the right tool. Although if you're in this group, you can still only make the part of the application that requires such a hack in standard HTML and JavaScript.
Yeah, there's probably some gross way to hack that where you're like, you take the generated JavaScript from Elm and then run that through some other process to like patch in your fixes.
I doubt it. I believe that a Hello World program in Elm is already, I think, like 2,000 lines of JavaScript or something, just because it needs to include sort of the core libraries and such, which in general, it's quite fast. But yeah, there's some small things. I wouldn't want to mess with the generated code because I think it's also sort of obfuscated by design.
Yeah, it's not a good idea. But people do it. If there's JavaScript, people will do stuff to it.
Yeah, I think there are better ways to achieve this in Elm, more like Elm.
I'm sure someone's thought through it.
Anyway, that brings us to the good parts, and we're gonna start out with a very strong suit. No runtime errors. Ever. Okay, this might not be entirely true. There are some theoretical edge cases where you can still get runtime errors, but I haven't encountered a single one, and I've made like 4 or 5 websites by now.
If you're
you will
dealing
not
with like
encounter runtime errors.
external state, perhaps, like if you're making a call to some external thing and there's some undefined behavior of the API response, or unless they've thought
So
through this.
if there's some undefined, so the thing is, if you do communication with the outside world, you will need to encapsulate that in some way to actually use it. You need to like parse that data, albeit interpreting it as a string, for example, and any interaction you have with the outside world will be sort of encapsulated in something that might be what you expect, or it might be a failure. And then you're forced to explicitly deal with the fact, like, hey, what happens if we get something unexpected? And then you can still decide, oh, I'm going to show an error to the user if this happens at runtime. But this is not a runtime error as in, oh, the compiler made a mistake.
Right.
This is a error that you give as the programmer. So you have the benefit here of being really specific in where this error came from and what a user should be doing, rather than JavaScript throwing some generic error at a user, 404 not found, or undefined, which can be really difficult to deal with.
Oh, yeah,
So in general, Elm has no runtime errors. So every time you write some piece of code that could fail at runtime by pressing some sequence of buttons, instead you will get an error, which nicely brings us to our second point. Elm has super helpful error messages. The error messages in Elm are, in my opinion, world-class. They are, from what I've seen, the best error messages, and I've been doing research about this for half a year now. They're really good at doing stuff like, oh, did you mean this? Or, oh, I think you are making this mistake. And then it will link you to some article to tell you, oh, this is how this error often comes up and how you might fix it. It's lovely, and that we'll get into more detail on this. Elm has simple syntax. Elm likes to have one way of writing something and one way only. Of course, there is no way to make a usable functional programming language by having only one way of writing something. There's a reason we're not all using lambda calculus to do this, which is about as simple as you get. But it tries to make sure that if you, as an example in Haskell, you could have a let statement and you could have a where statement, which sort of do the same thing, only the location and the way you write it down is different. Although just sort of the same thing. And they say, no, we won't have any of that. We only do let statements. You cannot do where statements, which is nice. The tooling is built in, as we've seen before. Installing Elm is really easy, and looking at packages or tooling and installing that is also, well, one of the easiest things I've ever done in getting a package to work. This is all great. It has awesome package documentation. This is sort of the counterpoint to making this package development harder. The standard website for documentation, the documentation, first of all, is in a standard format on their website, and I will show some examples of this later. Another great thing about Elm is that it adds some extra layer of abstraction. The main thing here is if you look at, for example, adding a border around a object, then in Elm you can say, hey, I would like to have this border, and then the responsibility of the package developers are to make sure that this will look the same on all browsers. And oh, if this version of CSS needs this method change for this browser, etc., you don't have to deal with this stuff. You don't have to deal with the deprecated methods and stuff that's been building up on JavaScript over the years. You can just use whatever the Elm provides you, and that responsibility is on the package developers. And therefore, it's not your responsibility. which really helps getting this to work. And another thing is standardization. Elm really likes everything to be the same, as in what I explained earlier.
Right.
You don't want they want your code to look like everyone else's code. They want your syntax layout to be the same. They want certain ways of expressing something to be the same, which also helps you write good code, because usually there's only one way to get what you want to work, and that way is also, it tends to be a very clean way of doing this. So that's the end of the good and the bad parts, and now let's have a look at the Elm architecture. So how do you actually make a website in some functional language? So the simplest model I can think of is some static HTML page. So we have a view function, and the colon here means that it is of a type. So this view function is of the type HTML. What we mean by that is that this function you can define, and it will produce some web page, which is nice. But in this case, just use HTML, because this now is a static page that doesn't really change. So we're going to extend this model to get to the Elm architecture. So the first thing we're going to add is we're going to add some model. So we have seen that we can create our own types. So we can create our own type, which has a model. And the goal of the model is to incorporate all of the data of your web page that can change. So if you have a counter, then in your model, there will be some number stored, which will tell you, hey, this is the current count. If you want to have a website with multiple pages, you'll have you can have a data type which tells you I'm on page 1, I'm on page 2, I'm page 3. And this view function will then take the information that is in that model and use it to generate the HTML. Of course, we need to have a so-called init function, which gives us the first state of our model. Because, of course, we need to say, hey, where should we start with our model? And then it might be nice to actually change this model over time. So we don't want to statically say, oh, in this case, the count is 1. We might want to increase the count to 2 and 3 and 4, etc. To do this, we have an update function. So what the update function does is it takes in the old model and it produces a new model. An example of a counter could be that your model is just some number, and then this update function can take that number and increment it by 1. However, your model might have various things. You might have 2 counters, or you might have both pages, and on some of those pages you have counters. So the problem is, what do you update? And the solution to that is to add a message. So a message is a data type that you can define as well, where you can basically say, hey, let's make an increment message to increase this counter. So that allows you to display, hey, I have this increment. This also changes our view function, because, for example, if we add a button to increase the to increase the counter, in our model, we do not only produce some HTML, but we produce some HTML that can sort of throw these messages to the update function. And this already works. The only thing is these are all pure functions. One input, one output, and in functional languages, it's not obvious how to do a loop that checks when someone presses a button, for example. Because this is a hard thing. You could do something with recursive functions and build on the fact that it takes time to unfold these functions, but we've already really solved this in JavaScript. So to solve this, we introduced the Elm runtime. So the Elm runtime makes sure that whenever you give Elm this like HTML thing that can throw these messages, the Elm runtime will in turn call this update function. And this really concludes the whole architecture. And every single Elm app will look like this. It will have some initial init function for the initial model. You will define some model. It has a view function that can create some HTML that throws these messages. Of course, you also have a type for these messages. And then you have an update function that takes a message and the current model and produces a new model. And these functions you all hook into the Elm runtime. So this is how you produce a website using a functional programming.
On the view function, you have model into HTML message. So that HTML message, can you like what does that mean? Is that saying that HTML is a function that takes message?
Yes, in a way, this is true. Well, the main thing is here, message is your own data type. And you need to tell HTML what kind of messages it can throw by providing it with this data type. But for now, just think about it like, hey, this HTML thing is just some representation of your website that can throw these messages to the update function.
Okay.
And understanding this model is really key. One of the things that is weird about this model is that it looks like you're regenerating the entire web page every single time this model changes. The nice thing, this is exactly what you're doing, conceptually speaking. In practice, the Elm runtime will make sure that it will only update the HTML and that it needs to. So the Elm runtime performs some optimization magic to make sure that this is actually an efficient way of working with things.
Cool.
But conceptually, after every time you see a you have a certain model, you will create some HTML and that will be shown. And every time you click a button and throw such a message, what it will do is it will be like, hey, I've clicked a button, I've shown a message, I'm going to ignore all the HTML that I've already had, and I'm going to take this new updated model and show you a new web page. So this is really a different way of thinking about how you represent a website. And the main thing here is that you don't have to worry about making this efficient. Elm will do that for you. There's one tiny thing. What we want to do is you can use Elm to completely replace HTML, JavaScript, and CSS. The point is we don't want to use any of that. By default, you can still do something that looks a bit like HTML, CSS, and JavaScript. So what we will be doing is we'll be using a package called Elm UI, which has something called element. And this element thing is effectively the same as the HTML. There's also a layout function that will just take such an element and convert it into HTML for you. So from now on, every time you see element message, think HTML message, because they act in the same way. They're just called different because this package needs to specify its own element, not to mess with any of the other functions that use the built-in HTML thing. So our view function will be a model to an element HTML, which will then be very straightforwardly be converted into a HTML view using the layout function to view this. So this is a small thing. So if you see element message, don't be confused. Just think element message is some representation of my web page.
Mm-hmm.
You can think of it almost as HTML and, well, the type of HTML.
Makes sense.
But this is all very nice and abstract. Let's look at an example. We can have a counter. This is going to be a very simple counter, which has a current value, namely 42, and it has a button, +1. And every time we click that button, the counter goes up. So the first thing we do is we look at our main function. So this is the Elm architecture. We have a main function which produces some program thing. We use the browser.sandbox function where we give our init function, our initial model, our view function, and our update function, like we've seen before. So we give our init or update and our view function to the runtime. Then we need to have some model. I sort of already gave this away, but what would be a good thing to represent a counter? What would you like in your model?
A counter of type int. So we have like counter type int.
Exactly.
Count int.
We use the record notation.
Mm-hmm.
The record notation is similar, as you might be familiar with dictionaries in Python.
Okay.
This just makes it easier to add things later.
What is that called? What are those brackets called, like in Elm? Do you know?
It's called a record.
Record. Okay. So we have a record that has a member element count type int.
Yeah, and
Field maybe.
I don't know.
Record and field. We can ask
Yeah,
ChatGPT.
I would think field is great.
In an Elm
Good.
record, what is a in an Elm record count? I realize I can't ask it what it is.
Yeah,
I need to know.
You're asking the question is now recursive.
Yeah. Count is a field in the record of type int. Okay.
Yeah, a field. Okay. So a field, and you can add multiple of these. So if you want to add a second count, you could add, for example, count 2 of type int.
And we can have a default value. We can put a default value in there if we wanted.
Well, this is just defining.
Oh, that's just the type. Okay, cool. Gotcha.
So our initial model function will indeed
there we go.
Initialize this model with starting with a count of 0. Because for computing science people, we like starting from 0 when counting. And that is our entire init function. Then we want to have a message. So the message is the thing that we will throw to our update function, where we are saying, hey, what are we actually going to change? So if you remember, our counter has a plus button, which will increase the value of the counter by 1. Do you have any idea how we could call that behavior?
Kind of similar probably to like the weekday thing where it's like we have it like an increment type. So type message is equal to increment.
Increment, exactly.
Yeah.
So whenever we click this plus button, we want to increment. So now now we know what kind of message we will throw. Let's make the view function. So the view function looks as follows.
Ooh.
So I'm gonna take that from the bottom. So the first thing is we have some text here saying hey +1, and we wrapped it in an element and give that some attribute, mainly saying hey, on click, we're gonna throw this increment function. And then for our 42, what we will do is we'll take our model.count. So that will be the count that we've defined before. And we'll take it from an int to a string. So in Elm, you explicitly need to convert data types. You cannot simply use a number as a piece of text. And then we use this funny operator. This is saying, hey, take whatever is on the right and put it into the function on the left. This would be the same as placing brackets around this thing. The nice thing here is now we don't have to count how many closing brackets we have at the end. We can just say, hey, everything on the right goes in here. I really like this operator, and I will have some more things on this later.
Yeah, it reminds me of the like Unix pipe operator. You're just piping data through to functions.
Yeah, there's some nice things to prevent brackets. And then we will take that whole thing as text, and we will also wrap it in an element, give it some padding. And then these two elements, or these two elements, we will put them into a column which itself has no attributes. The nice thing about these attributes, as you've seen, we can do stuff like padding in here, or we can do onClick. Another thing which is really nice, especially if you worked with JavaScript a lot, you can just enter center X, center Y, and it will center your element. And you don't have to deal with difficult transformation to center an object in CSS or whatever. That's just built in. And then finally, what we need to do is we need to update our update function. So our update gets a message and our old model, and it will need to produce a new model. So the first thing we do is we say, hey, case message off. What that means is let's look at this message and see what it looks like. So if this message looks like increment, what we will do is we'll take our existing model and we're going to make a new model, but we're going to change the count to be the current count +1. Does this make sense?
Yeah, so we got our update function where we take message and model, and then we're switching based off the case of what our message is. That's a little strange. Like the English doesn't quite work. Case message of, so we'd substitute case increment, or I guess case. That's a little strange, but I understand.
Yeah.
And then when we see.
So this case thing is a really elementary thing in functional programming.
Yeah.
Where it allows you to inspect what a type looks like. And we will see this a bit later in the assignments.
Is there a way that you could like explain that case message of like in like an English sentence that would kind of like parse a little better?
Moment, please. I'm being
case message of, like you have like different cases.
So it's basically saying in case this message is of type is of something that looks like increment.
I like that. Like in case we see increment, then we are going to take our model that we previously had, and then we are going to update our count field so that it is the previous value of our model's count, but incremented by 1.
Yeah. And in this case, we could have also removed all of this and just said model.count +1. But this just gives us some standard structure in case we want to have, for example, a decrement as well. Then you could add a case below to decrement it as well.
In JavaScript, people might this is very reminiscent of how Redux works, where you It's almost the exact same thing. It's just this is a more succinct syntax to express what it does. Like you'd be
Yeah.
like unpacking model instead of I don't know what you refer to like model pipe.
Well, yeah,
Pipe is in that.
this is effectively unpacking the model,
Yeah.
like model.count. This is sort of borrowing from the object-oriented style where the dot basically means look into.
Yeah.
So take the model, look into it, and get out count. And then this notation is just saying, hey, we're going to have this record and we're going to only change this one thing. Which is especially nice if you add extra stuff in there. Because then you don't have to change this increment function to deal with the extra data that you added to your record. That's the main reason you would use a record in this case.
Right. I remember now why Redux is like so annoying to do, because it's like because we're in JavaScript, you to express your message type, you start with like creating a new constant like increment that is of type like string, and then it's like increment. And then the action creator is like the thing that initiates it, which is like oh yeah, it's just so god.
Yeah, it's just it looks like a weird workaround to make your own types, which is just straight up supported in something like Elm.
Cool.
Okay, so now we get to a more practical section. On my end, let's actually look at what it is to use Elm.
You're being hacked.
It's fine. It's working. So this is I'm gonna like that. So this is Elm. This is Ellie, the online editor for Elm. And we like Ellie because it makes your life a bit easier. Because you can just type sort of. The first thing we're going to do is we're going to close the HTML tab because we don't need it. And what you see here is exactly the code that we just implemented. So we have our main function with the init, view, update. We have our view function that we looked at. We have our update function and our initial model. And we have the two types that we made. The only extra thing is that we have this HTML view thing to manage with the package. We don't even have to look at this. It's just necessary to pass the right thing. So, as we can see, this works now. And we're now coming to one of the most beautiful things in Elm. And that is what they call compiler-driven development. So let's say we want to take this code, and we do not only want to have an increment button, but we also want to have a decrement button. So what we do is we take our code, and in our view function, we are like, hey, well, let's just add a button, and instead of onClick being increment, let's make that decrement, and let's change the text to -1. That's a logical first step to add in a button. The main problem here, we haven't really wired up this button. We've just invented a thing called decrement, and we haven't really done anything with this. So we need to wire this up. And we could sort of be smart about this and figure out, oh, what are all the things that we need to worry about? What we can also do, we can just click compile. And then the first thing happens is that I
like the first person errors. I always laugh when I see that. I am partway through parsing a list, but I got stuck here. It's so cool. I guess that's to your point, the assistant. It's the assistant versus like a compiler.
Yeah, it tries to be really friendly in tone. But in this case, this slash didn't need to be there. I think I just accidentally hit a button on my keyboard. Anyway, if I click compile here, it will say like, hey, this decrement thing, I cannot find a decrement. It will nicely highlight where it is. It will also show, hey, increment is a thing that could be here. And then it even gives us a nice hint saying like, hey, on this website, you can find how import declarations work in Elm. Because we might have been trying to use something from a library that didn't exist yet. But in this case, we can be like, oh, well, it makes sense that there's no decrement because we never defined it. So we go to our message and we say our message can be increment or decrement. And we can click the format button to get the standard formatting. So our message is now increment or decrement. So we've basically fixed this error. So it cannot find decrement. We add a decrement and we just click compile again. Oh, now it's complaining, hey, this case does not have branches for all possibilities. So we have a branch for increment, but hey, it says, hey, the missing possibilities are decrement. And it says like, hey, if I saw this branch, I would have to crash. And we don't want crashing because we don't want the runtime errors. So let's take our increment and just make a copy of it because I think decrement is similar. And say, hey, decrement. And well, since we're working at this anyway, let's, instead of incrementing, decrement the model. And we click compile. Hey, it works.
Amazing.
And wouldn't you know, it's actually implemented correctly. The nice thing here is that this way of working, where you just add something in and then follow the errors until it works on dumb big projects.
Mm-hmm.
Like I have a like a few 100-line piece of code where I needed to change this browser.sandbox to be something with a lot more information. So I needed to change my init, my view, and my update function to account for processing this extra information. And normally that would be a really big refactoring, but I was just fixing the errors one by one, and it took me less than 20 minutes to update my entire site to work with this new data, which is really nice.
Cool.
Another thing that they point out is this fearless refactoring. What they mean with that is you can do these changes also for refactoring. So you can just define, oh, I'm going to put this in a new type. And then you just keep pressing compile and fixing these errors one by one. And the compiler will sort of guide you through the process of making sure that you do this refactoring consistently everywhere and that you do not forget something. Because the type system is strong enough that it can check this kind of stuff, which is a really pleasant way of working, if I say so myself. Another thing I'm going to look at a bit more is the great documentation. So the documentation site looks a bit like this. For example, this is the standard documentation for strings. One of the nice things here is that it will not only be like, oh, there's this type called string, but it usually gives you some examples. And in this case, it also tells you some interesting stuff like, hey, you can escape certain Unicode characters, or hey, you can use the triple quotes to get you to do multi-line strings, which is nice.
I think standard documentation is the single most underappreciated thing for a language. Like,
yeah,
it is the thing that differentiates like an okay language from a great language. Because like, if all you have to do to understand like the language that the programming language wants you to speak, like, is opening up a site and just like running through like all of these things and seeing examples, like, you just immediately have it uploaded into your brain. Like, I know exactly how to use Elm because I'm just like looking through the docs.
Well, it's especially nice if you're beginning.
Yeah.
Because once you get used to this, you will start to sort of learn these functions and the things that are relevant, and you will hardly look at the documentation anymore.
Well, I think what's interesting is like I don't think it ever like it goes down in value, because it's like knowing that there's being able to confidently
Well,
program and fearlessly program, knowing that there's good documentation to support me when I don't know the idiosyncrasies of how trim left works. And I just know I go to string trim left, and then it's like, oh, okay, these are all the things that trim left could do.
yeah.
It's just like, it's so reassuring. Like, I feel like I can just trust the language so much more.
Yeah. So another thing that I would like to point out is if you go to any module, in the About section, it will tell you the install command to install a certain package into your project. And I've never seen this be more than 3 lines. So that should tell you something about the installation project of packages. And of course, it has a decent search function where you can search for the modules. And here again, you can see trim, and you do not only get the type and some description of what it does, but you usually also get an example. There are some cases which are a bit more abstract where an example is harder, but they tend to give you common cases where a function is used, some examples to aid in this documentation. And this is what I really like, especially for beginners, that this documentation is really friendly.
Cool.
Then about these packages, I would like to highlight some packages, which I think are nice. One of them is Elm Visualization. Elm Visualization is a package that will help you make certain graphs, and I think some of them are really cool, and you can get the Elm code that they use to generate. Of course, this is a bit of a complicated example, but this is to show that you can make like complicated stuff with libraries. There's not a library for everything, but for most things you would want to do with web development, there are some really cool packages that can show you different data visualizations,
And this is
etc. And
this
the
is
nice
probably
thing,
getting ahead of the thing, your presentation, but like, even if you can't find something that's exclusively Elm, there is always, because it's JavaScript, like the ability to use any other JavaScript library if like you really need to.
yeah,
like,
we'll get to that.
Yeah, we'll get to that.
I have a few examples of where I actually encountered this. So this is nice. Of course, these visualizations are a bit complicated. I mean, if you look at this, it's not too much code, but
Take a second to figure out.
yeah. So another thing, this one, which is a bit easier, is something like Elm charts, which is a really nice language where if you go to the documentation, we can, for example, look at some nice like line graphs, and this is the entire code
Cool.
that is used to generate this chart. This is already a bit more approachable, and of course you can get like the update and view functions in there, but the essence is a lot simpler.
What is that? That is showing
And
the essence? Is that just like the view?
yeah, that's like
Function,
everything without the
Yeah.
view
Okay. Okay.
and stuff like that, because sometimes you need a bit more like every single Elm thing for it to compile will need to have this view, this update, and
Yeah.
this init function. Which
That's a
in this
cool
case
idea
is,
though. Like the fact that you can show like the essence, and like that's still like meaningful.
well, it is basically taking away all the standard boilerplate that you would have to do regardless. And there's some really nice charts in here, or there's some like nice interactive things where you can be like, oh, let's
Ooh.
do stuff like this. This is just to show, yes, the Elm user base is smaller, but you can make all these. There are libraries to help you with the useful things and making stuff nice and interactive. So for web development, there are a lot of cool packages. Give me 1 second.
Cool.
So uh, there is, and then we get to the other thing. I own an accordion,
Oh, cool.
but I am mainly a piano player. So
Mhm.
this side of the accordion, that's going fine. I know I know how to do that.
Yeah.
This side of the accordion, I have no clue. I should have prepared this better because I am used to giving this presentation in a place where I cannot demo this.
Do you have your accordion
But
with you?
I mean, yes, but that was not what I was doing. So the thing is, I also have a MIDI keyboard. I hope this. Oh
Ooh.
yes, it works. So what I've done is all these buttons on the right.
Mhm.
I can lay them out schematically here, which will show you what the notes are and also what the chords are.
Mhm.
So if I am like, hey, I would like to do a G minor chord, I can do a D, an F, and an A. All right, and I will get my D minor chord
Mm.
highlighted in green. The thing is, I am used to playing piano,
Right.
and I know these chords on my piano, and I have in front of me a MIDI keyboard.
Mhm.
So what I can do is if I press a chord,
Sick.
it will highlight
Is that playing through
the
the
correct
page as
notes.
well? Like, is it playing the
Oh
note?
no, that's on my end. That's the audio
Ooh,
input
that
setup
had nice.
that
That
I
had nice sound.
got going. But I can change the chords on my keyboard and
That's sick.
immediately get the correct button. However, in order to get this to work, like at all, I need to do MIDI input. The thing about MIDI input is that there is no Elm package to do MIDI input,
Mm.
which is annoying. However, what you can do is you can make Elm interact with this with some existing Elm package. So this is just describing the interaction. So I just looked up some like JavaScript library to handle MIDI input, and there was a website that says, "Hey, get this working within 5 minutes." Within 5 minutes I could press a button and print it as some text in the console. And then what I've done on the JavaScript side, whenever you start a Elm application, you can use it as such an init function, and then you'll get a variable called app. And then I could add a listener that every time I press a note, instead of sending a message to printing it to the console, I could replace it by app.boards.messagereceiver.send, and I send a piece of string. And in my Elm code, I could define this port saying message receiver. And then there is a subscriptions where I can say, hey, this message receiver will get some message and put it into MIDI in. And here in my type for the messages, I have a MIDI in that takes a string. And this is more advanced, and this is not something we will be looking at today. But from my experience, I can say it was relatively simple to get the strings from JavaScript to Elm, and there exists a similar way to get messages or some data from Elm and give it to an existing JavaScript function. So these ports go both ways. And this way you can get something like an existing JavaScript library to work with your Elm code. And the nice thing here is that this string thing needs to be in somehow processed by your program later
Mm.
to get this to work. And of course, if you mess something up with the message that you sent in here, the string will just be empty whenever it gets received. So I have another example of something that you can make in Elm. So this is actually the website that we're going to use to do the exercises. And this website is, it has some tabs, and it has a quiz section where I can click an answer and get the next question. For example, Scient have shown that they find 7 the most random number. What is the most random number? No, it's not banana. It's not a number. Oh, 8. 8 is closest to 7. And these questions, they're like, they make no sense. But it's to show that this website works.
Mm-hmm.
The nice thing here is that one of the things that functional programming is really good at is parsing stuff. So this website, what it does, it loads this text file every single time. So I have, for example, the question about numbers. I just say text, hey, scientists find 7 is the... Then I have a question, what is the most random number? And then I say, this is a wrong answer, this is a correct answer, this is a wrong answer, wrong answer. And how this website works is every single time this page is loaded, it will take this text file and transform it into the HTML. So the nice thing here is that if I wanted to change this, add questions or add more sections, I just have to change this text file. I don't have to worry about any source code. So I've effectively made a domain-specific language for making quiz websites.
Sick.
And this is one of the things that was relatively easy to do in Elm. And trust me, don't look at this code. I've gotten a lot better since I made this. This is one of my older projects. But the fact that this just sort of worked as my second project that I ever did in Elm should say something about how you can sort of manage this and make sure that it doesn't go wrong all the time. Where in JavaScript, something like this would be much harder to do.
Right. There's many different ways to do that in JavaScript versus I imagine that there's much fewer ways in Elm, which is a good thing.
Yeah, I would say. So this is sort of the end of the talk. However, I still have some slides left. These slides are mostly aimed at existing Haskell programmers. But in general, I think it's nice to sort of go through them and sort of get out the essence. And these are mostly for syntax. So a thing for Haskell programmers is in Haskell, you use 2 colons to determine a type. In Elm, you just use the 1. And in Haskell, you have this complicated type classes stuff. Well, in Elm, they don't do that. However, the way you actually write the function is the same. You can create your own data types. In Elm, you use the keyword type, and it follows by the names. The nice thing here is that the standard formatter, it really likes space. So it will not like, hey, sheep, cow, chicken on one line. It will format them on different lines, which is a bit strange because all of a sudden you get a lot of lines of code for something that is fairly simple. But I found that since most of the time you are following the errors from the compiler anyway, and I would like to point out that if you use something like VS Code with the correct plugins, this becomes even better than what you get with the online editor. Having it take a bit more space can often be a very nice way to keep things separated. Another thing that you need to do in Elm is if you want to have a yield from animal that takes some animal and takes it to a string, you need to use these case statements, and you need to use the standard formatting that Elm provides, which is quite long, even though the same piece of code in Haskell could have been done way shorter. And Haskell has this way of doing sort of this case statement inside of the name of the function, which makes it a lot more concise. And Elm doesn't support that. In Elm, you need to do the case statement explicitly.
Right.
Another interesting thing is to look at how you do pipelining, like you've mentioned before. So in Haskell, you could use the dollar sign to basically say, hey, I want some input, I want to trim it, then I want the lines, then I want it to an integer, and then I want to make sure that I only keep the ones that are actually converted to an integer. So you can imagine the brackets being like all the way where these dollar signs are, and then end with a bunch of brackets. Haskell has this dollar sign to make that better. In Elm, you use the pipe operator, like we've seen before, which is say, hey, everything to the right, put it in the function on the left. However, what I find especially nice in Elm is how you can flip this operator to make it work the other way around. And you might want to move your camera in the thing so people can actually see this. This one is kind of important. Yeah. So you can sort of do that with function composition in Haskell, but it's not nice. However, in Elm, you can use this bar arrow notation in the same way you use it here. You just put the arrow on the other side, where now your data flow is a bit more logical because we as humans tend to write top down instead of from the bottom up, which might be used to. So you can say something like input, and then we're going to trim that, and then we're going to split it into lines, and then we're going to map it to integers. And this gives us a really nice way to represent a data-oriented way to express our functions, where we start with our input, and then we work down transforming our input in each step, which I think is a lot nicer than sort of doing that backup or passing them all into functions, even though these two are completely equivalent in terms of writing it down.
It's pretty cool.
Then a short thing about records. You can have something like a person with a name and an age, and then here we see the notation again where you can say like, hey, we can take this person and instead we increment the age. The nice thing here is that this doesn't change the name of the person. So in this case, we have both a name and an age, and we don't have to deal with that. And in Haskell, you have similar notation. Then a thing about lists. Lists in functional programming languages are a bit weird, since a list is defined as being a head and a tail. So you can define the list as the first element in the list, and then the rest of the list. And what you can do is you can do some pattern matching on that. For example, here we say, hey, if the list is empty, we can check, hey, this is the symbol for an empty list. Then, yes, this is in fact empty. Or here we say, hey, this is some element, x, followed by some more elements. And these x's can either be more values, or they can be the empty list. And in Elm, you would pattern match like this. The main difference here is if you look at something like Haskell, they use a single colon to separate elements, and Elm uses double colons. And it also does away with the brackets at the end. So if you're coming from Haskell, that's something that might trip you up once in a while. Just know that like the list separator is called concat. If this is a bit confusing, we might see some lists being used in the examples. And that will be the end of my presentation.
Very good.
So for now, let's go to the quiz site, because this is also where we have our assignments. And I put that in chat. I'll also send it directly to you. And yeah, you can turn off my stream and start having a look at these exercises, where I highly recommend starting with the counter.
Okay, so we're starting with the counter. In this section...
Well, yeah.
What's that?
Well, my point is the demo section is just some bullshit questions to show that I import this from a file.
If we take a look at the... is it all just embedded, or are you like remotely pulling it in? Oh yeah, there you go. You're pulling it in via like a HTTP request.
Yeah.
Very cool.
I'm just getting the text file.
Cool. Counters. In this section, we will continue. Oh, and so all these questions are built from that thing that you built.
Yeah, so the counter thing sort of goes through and building on the site. The nice thing is that I have a bunch of links here.
Very cool.
Or is it...
Oh, we don't want to cheat.
So the counter example, like if you want to see the source code, I also linked it under the resources. You can just, I think I linked it under.
Yeah, there's the code.
And this will open up the online editor.
Yeah.
And I recommend making that a tiny bit bigger so people can actually read it.
Okay.
You can write the HTML. And yeah, you can read the first exercise and sort of start working through them.
Recall we introduced a minus button, which sends a decrement message. As we go through the exercises, we will keep sending these links so you can study our solutions or skip some exercises. Repeat the demo by copying the button in the view and making it send a decrement message instead. Okay.
So you can look at the demo. It currently doesn't.
We're going to copy our increment.
Yeah. And so the first thing I notice what you're doing here is you're already you're doing everything top down. As in, you're thinking about what we need to change and what we need to do.
Yeah.
It's often better to just start with the button and then just keep pressing compile
let's try
and
that
see
out.
if you can fix the errors, because that can really help you sort of understand these error messages, because when you see them for the first time, some of them might be a bit weird.
Text -1. Okay, so we expect this to give us an error. I cannot find a decrement. These things are close because we need to introduce decrement.
And what you can also do is you can press the format button on the top right of the editor.
Cool. Okay, so now we want to increment or introduce decrement in here. I love learning languages. It is so much fun to like experience how other people like see the world.
Yeah, and I'd like to point out that this really is a very different sort of style of thinking about websites than what you might be used to. Because there's a lot of things.
What's interesting is JavaScript over the years has been becoming this, but because of how fucked the language is, it can't get to here because it's another language is what they really want. But like the hive mind of JavaScript developers and like everyone wants this. Like I've seen people try to recreate this so many different times in so many different ways. And like I said, this is just Redux. Like the whole update thing, like that's all that library does. This is React, like the model, this view here, and our store, like, or the types. I mean, there's very little conceptualization of this because TypeScript is so recent and it's done such a kind of more or less like poor job of expressing it succinctly. But that's just because this is influencing.
It's also worth noting that TypeScript isn't actually type safe, which is not great.
Yeah.
Like it helps.
This kind of looks right. This kind of is like the thing that you want, right? Cool. So I think I got a working counter now. Well done.
You can press the button.
Code with both buttons. So we have our thing.
Yeah, so this is my model solution to what you just did, which I'm pretty sure is identical.
Sweet. Okay, so now that we have a working counter, now we will try something. You need to check your grammar in here. Now we'll try something. We got no instead of KNOW. That's okay.
Oh.
We'll try something a bit more challenging. Let's say we want to add more buttons. Can you fix it in real time? I guess you just pull up the file.
Yeah.
Let's say we want to add more buttons to change the values. Then it would be silly to make a new message for each possible amount. To solve this, we'll update our message type to increment int. So we will remove decrement and add an int as a parameter to increment. Implement this new message type. Feel free to add extra buttons. Again, make sure to compile often to get a feeling for the error messages. So we are removing decrement to make way for our new form of increment, which takes an int, which is an amount, and we're doing top down. Okay, or we're doing the other way. Okay, so we want increment to now take an amount, a variable amount. So let's say 5. So instead of +1, it's +5. And when we run this, the onClick function expects 1 argument, but it got 2 instead. Are there any? So do we need parentheses here?
Yes, you do.
Okay. So now
you could also use the caret, the caret bar thing.
The caret bar?
Like the smaller than bar thing.
That?
If you'd like. And then, yes. And of course.
Oh, interesting. Okay. Do I like that better? What do I like better? I don't think I like that. I think I like the parentheses better.
Yeah. The main thing is at some point you start getting functions where you have like 20 nested parentheses.
Yeah, right.
And you get that a bit quicker with this functional programming stuff. Then it becomes really annoying and can be better.
Well, if we have the pipe that goes the other way, could we do something like increment 5 pipe on click? Is that?
Yes.
That technically works. But that's weird. I don't.
That's.
I don't think that quite makes sense.
Also, usually you would only use that operator when you're like splitting it out over multiple lines, so like the data flow is a bit more obvious. But you can do it, and there are cases where it could make sense.
Okay, so I think this is definitely the right way we want to express this. And then it says the increment value is not a function, but it was given 1 argument. Are there any missing commas or missing parentheses? Well, we know that we want this. So now we need to update what increment is described as. And we say that we just have our type increment here, but maybe we want increment int. So now we have on line 29, this thing says, well, we know increment int is the type that we want, but we don't have it here. So now we need to say increment, and then we probably want some like a type, like amount, increment amount.
Yeah,
Is
so
that...
a thing here is
Oh.
amount is all types start with capital letters, and amount is not a
Amount is not a type, right? Because we want, this is like a variable. And then we just put amount there. So we didn't get a compiler error. That made sense because it was, this is technically all valid, but we're not using amount. So this is where like our beautiful type system comes like at its shortcomings, because now we need to like actually apply our logic to the situation, and that's like by changing that. So now if we plus 5, we can increment plus 5. Sweet.
Hey.
Very cool.
And can you also make it, for example, decrement -5?
Yeah. So we'll go through again. L on click decrement 5 text -5. We run this, we get, don't know what decrement is.
So here I would still use the increment message.
Oh, haha, very good, very good.
So the whole point of this exercise was to remove
Beautiful. Beautiful, we love that.
Now you have an increment and decrement.
Right. Probably want to change what that's called, but that works. So cool. I have a working counter again. Very good. Great. But these buttons look kind of boring. Let's do some styling. To help you get started, let's focus on getting the entire counter in the middle of the screen first. To do so, we will use the center X and center Y attributes. Add these attributes to the column containing our counter. So we got our column, and we didn't talk about this in the presentation, but I do know that this is the attributes, or I think you did mention it.
Yeah, I mentioned it.
Center X. Oh, this is so cool. That is so cool that it's like you type it out like in browser. Like, okay, so putting this content into like perspective, if I wanted to do this with JavaScript write online, I don't even know where I would go, like, because there's so many of these things, and it's like maybe you get type information, but they're sure as hell not going to link you directly to the docs, because this is only possible because everything's strongly typed. And I go here and it's like, this is a package. Yeah, it's like some dude's package, and then we go directly to where center X is defined, and you know what that is.
Precisely.
And you
even in this editor, you can in Ellie,
you
can click on the top left. There's like a cardboard box icon
to see all the packages. Yeah, we got Elm UI.
And then you can see all the packages.
So cool.
And Elm UI is making sure that we can actually not use any HTML, CSS, or JavaScript. Otherwise, the default Elm, I believe, has some amount of CSS.
Sick. What does the CSS look like for this?
Counter is in the middle of the screen.
Very cool. I do have some opinions on the like UI frameworks, but that's kind of like more of like from like the web application perspective. And eventually, I mean, all of these things are effectively just like a DSL for expressing UI anyway. So there's certain things about expressing UI that need to exist in order for it to be as robust as what's needed to build like an application for like Netflix, for example. Like, how do you build Netflix? And I would postulate that what's available here through this UI, like Elm UI, is not sufficient to do that. But that's okay. This is perfect for learning. This is like exactly what I want if I'm doing this exercise.
To defend Elm UI, there are some things that Elm UI does which are really impressive.
Mm-hmm.
For example, there is a presentation on, for example, doing color gradients using Elm UI. And like, they did stuff like spend a lot of time on dealing with proper gradients, as in, depending on the color space you use, your gradients look weird. And the one color space where they don't really look weird is linear HTML, linear RGB, and they made sure that that is the default, and that you don't have to do any dumb stuff about it. I believe I might have a nice example of that.
This is pretty sick. Someone made like an Elm UI patterns like example thing.
Do you remember? Yeah. If you look at my screen again, you can see how like different color spaces have different gradients between colors.
Yeah.
And here you can like change stuff like.
Ooh.
But here you can see, for example, RGB gets really sort of dark and swampy in the middle, really brown. While HLS gets super bright in the middle, and linear RGB is one of the only ones that sort of consistently retains some semblance of like.
That's a pretty cool demo.
Terrible.
Yeah, that's pretty nice.
And linear RGB in most cases tends to be a more friendly space, where, as you can see, you can sort of see these bars moving around if I start messing with the color spaces in the gradients, which are weird. And the nice thing is that this linear RGB doesn't really seem to have them. It just sort of does gradients. And that is one of the things that they spend a lot of time working on. And there's a lot of small stuff like this where it works. And thus far, I haven't seen many things where Elm UI would not be suitable to create the UI.
Yeah. Yeah, and I think I'm thinking of like the deeper that you go into like design, there's actually this would actually be a really cool presentation that I could give, is on building like just designing a website. Like there's so many things that that you can consider that are very foundational to the way that we perceive things as humans. And this is something that I've been studying like the past year, is like, how do you communicate information to people? And it becomes quite difficult. Like, we have like an ideal thing where everything's like a grid and everything fits into the grid, but like humans don't want to see grids all the time. There's a reason why not every site's just like an Excel spreadsheet. Like we need like different levels of visual information coming out at us. But anyway, Elm UI is perfectly fine for what we're doing right now.
And to add to that, like, there are some things where Elm UI, where like, for example, animation. Animation is something that is relatively easy in JavaScript, and that is just inherently a bit more difficult to do in a pure system such as Elm.
Right.
Because you need to deal with a lot more information that you need to keep in your model. For example, there's different ways to get these animation things to work. And the same person who made Elm UI has a wonderful library, which I believe is called Elm Animation, which you should be able to find through the package manager of Elm. So it's not simple animation. If you just click the Elm packages and search for animation. No, that's
not this one.
Yeah, I'm not sure.
Wow. I searched for animation in the package manager, and then it said, hint, if you're not using CSS animation, you will need on animation frame. That's crazy.
Yeah,
That's so
it's
nice.
the one by McGriffith,
McGriffith.
Elm Animator,
Check out the talk that
which
goes at
is
the library. Sick.
yeah, it has a nice talk with it. That like this is the same guy who made the Elm UI, but the thing is, there are some difficult things about getting animations to work, and I wouldn't say it's like difficult, but you need this like whole framework and tooling to make it somewhat usable. Where in JavaScript, this is sort of working by default
Mm.
because you can just tell something to rotate or to disappear or whatever, and that just works. But the problem is, as soon as you delete something at the logic end of your application, it no longer has this information because if you remove it from your model, it is gone.
Right.
So you need to sort of make a duplicate of your model just for the animation state, so you can do stuff like exit animations, so that you can remove a item from your list and click save and don't have to wait on clicking save for the animation to actually finish.
That makes sense. It looks like this just like yeah, just uses CSS to achieve it. Which is pretty nice.
Yeah, but the nice thing about Elm is that it is impossible to write illegal CSS in Elm.
Yeah.
It will just tell you like, hey, you can do it. Okay, impossible might be a bit strong. I have no way of proving that.
It's more challenging because you're dealing
it
with
tries
a
to make it
mutable
impossible.
state, and it's just like that's so much state to keep track of when you're dealing with like frame rates
Yeah.
and like movement. Like it just doesn't make sense to manage an Elm. At least how it's currently implemented. Maybe there's a future iteration where it becomes more feasible. But cool. So we got center X, center Y. That looks good. We got it. Great. Your code should look like this now. Most elements look roughly like this. Element, list of attributes, list of elements. Where the elements are things like L row, L column, and the attributes like center tell how it should look. There are many kinds of attributes, but the most useful are padding, center, width, height, background color, background border, and font size. See LUI documentation for more of those. You can wrap something in a element, no attributes, my element, to add place for attributes. Make the buttons look more like buttons. Okay, so I'm going to look at the documentation.
Yeah. And I'm going to get a glass of water, so
cool.
I'll be right back.
So I probably want to get a border around these guys. So we got our text. And I'm going to wrap this in an element. Wrap that in an element. And then does that work? No, we don't like that. This argument is a list of type list element, but L needs the second argument to be an element message. So we just don't do the list around that. Compile. Nope, still don't like that because this needs to be parentheses. There we go. So I want a border. To get a border, do I just say solid? Nope. Solid. Do I need to import it? It's imported. Border.solid. But we don't have a color. Maybe. Border style solid, but we don't have a color. Color, border.color. And then it takes a color. So that's going to complain.
I've returned.
Hello. Let's see. I need to figure out how to make a color. Are there names? Are there color names that I get access to, or do I have to build like a color with like the numbers?
So you can. What I usually do is I build them myself with RGB. There are packages like Elm.color, which just provide you with a bunch of colors. But I don't think I included that with this one.
That's fine.
And if you're going to use 255, I recommend using the RGB 255 thing.
What is that?
There's a function called RGB 255
for
specific.
Very good.
Because otherwise you need to work with floating point.
Don't want to do that. Not now.
Yeah.
Okay, so now we need to import element.color as color. You're trying to import, I checked dependencies, but it's not there.
Yeah, you don't have that package. You don't need to use the element.color thing.
No?
This color is already part of the...
Oh, I see. It's part of element anyway. Oh, we already have it imported.
Yeah.
But it can't find color. Do I need it?
So if you... So this is just element. I think you can just use RGB 255. I don't think you need...
Oh.
I'm not sure.
First argument to color is not what I expect. Let's just make sure that it's working with some parentheses. There you go. We don't see it though.
Yeah, you set a border color, but you haven't actually set the border yet.
I said solid, border solid. Do I need to also have like a width?
Yes. Because you now have a solid border with 0 pixels.
0 pixels. Let's go. Too much border. Chunky. Cool. Am I getting ahead of myself? Because I have I was thinking about moving this out to like its own function so that I can reuse it.
Not at all.
We're starting to get longer. Let's see if we can do that.
Do your worst.
Yeah, let's see. Well, so we know we want a button, and our button is going to be of type element, I believe. And it's just and then we need to take a. So what do we want? So we want a number. We want to take a number, which is the amount that we want. So that number is an int, and we're gonna say button amount, which is our int, is equal to, and then we're gonna chop this up. Come on. Let's see. So we're gonna
nice thing here is that you can like add a few enters and press the format button.
Oh yeah.
And it will make it sort of look nice. Because I think you need to have at least like one enter to tell it to be like, hey, go on beyond separate lines. So if you do the one enter and then press the format.
Nice, that looks much better. I can actually see what's going on. Okay, so amount just goes right into there. We increment amount, and then text, we need this to become text, and I believe that was like we want to find string. How do you see the standard?
That's in the Elm core.
Elm core. So we want to go core.
If you go to the start of the packages, then
string.
Yeah.
Let's make this bigger. Cool. So Elm string, and then I want to find string from int so that we get our string. String dot from int and then amount. So now I think we can replace this whole thing. Get our thing back. And I think we can say just button with amount 5. Element dot something? Element dot element?
It's element message. In the same way that the view has an element.
Oh.
It needs to know what kind of thing it can.
Ah, cool. Second argument is not what it expects. Oh, do we need to do text now? Say text from that?
Yep. And then here it is nice to use the pipe argument. Because otherwise you're going to have to put that whole thing in brackets.
Cool, nice. I like that. That makes sense to me. That's elegant. That feels right. Because we built our function. We just popped it out. Still type safe with our type message.
And what you can do is if you add an enter after the second L in the button function.
Second L. So I do that and then hit format.
Yeah.
Sweet. Perfect.
Then it will like use the standard formatting.
Okay, so now we can rewrite this one too and just say button -5. And now we have our other button. Cool. So now we just focus our styling on this. And I'm sure ChatGPT could give us a more aesthetic looking button. Update this Elm button, Elm UI button, so that it is blue with nice rounded corners and padding. Let's see how well it does.
You might also want to give it the imports that you have at the top.
I think it should be fine. I think it would work. Yeah, it just starts coming up with them.
The thing is, I think those align. But the thing is, I have like import element border as border.
Yeah, I'm just interested in this part.
This will probably be fine.
Wow, that doesn't look nice, but that's okay. That's because that is weird. It's a little better. Probably want to figure out how to get like consistent width between those, but and then the click isn't quite right. We want to put the click on our parent element here.
Well, actually, why are you putting two elements on each other?
That's also a great point. We don't need that.
At that point, just have that be the text. And then like don't ever manually do the formatting.
You just hit the button.
Always better. Because you're gonna click the button at some point and it will auto format it anyway.
It's so far though. I want it to like come a little closer. I want it to like appear, I don't know, like maybe over here, like as I'm on the line that I'm typing, to just like.
I mean, if you're actually gonna use this, I recommend using the VS Code one, because that will also give you the types automatically. As in, you don't have to put on line 38 that you have the type of the button. If you remove that, it will automatically be like, hey, would you like me to add the type int arrow element message for you? Because giving this type is not necessary. So
line not necessary.
So line 38.
On line 38.
You can remove that.
Really?
Yeah.
That's not necessary.
Nope. That's completely optional.
What? Because
Because
it just
that
infers. It just infers the
it just infers it.
Damn.
Yes.
Oh yeah.
Because it on a technical level, it turns out that inferring types is easier than checking if something matches a certain type. As in order to check if your code matches the type that you specify, it is easier to infer what the code is, ignoring the type completely, and then checking if those two types are the same.
Mm.
But in general, it's a good form to add the type in anyway.
Yeah, I like the type. I like.
But the nice thing here is if you now do button and then int.
Button and then int. What do you mean?
Or like if you make both of them int, like.
Both of what?
So if you just make the type int.
Just this?
Instead of int arrow element message.
Yeah.
Then you can click compile.
The type annotation for
and it will show you something like, oh,
0 arguments.
It has one argument. So then you add an arrow int to it.
An arrow int?
To the button.
That's not going to work.
And then you click compile. And then it would tell you, hey, the second thing is element message. And then you change the type to element message.
Oh, it just knows. Oh, wow.
Yeah, it just knows.
Wow. That's sick. That's so cool.
It can like always figure that out.
Oh, yeah, capital message. So cool. Also, I'm totally going to insert some JavaScript into this page. So if I like click on a line, it runs the auto formatter. Because that would be useful. I mean, I like coding in the browser sometimes if I'm like proving something out.
Yeah, well, if you're gonna like do this, just use VS Code.
Yeah,
like
but
the
like
browser
sometimes...
is nice because I can give you some examples here.
Yeah, like if I'm like
for example,
just thinking
that
of something.
trick that I think I can just show you this. I'll set this up. This might take a sec.
Cool.
You continue doing the.
Oh no. My buttons look absolutely fabulous. No, I got the wrong answer. That was the right. I had to say they're fabulous. I like the spirit. Now have a look at our solution. Let's see what the solution
is. All my things are automatically open in new tab.
That's fine.
I won't let you.
Ooh, button styling. Where's that? Button styling list. Very cool. And just break it out. And then
so the plus is just add two lists together.
Add two lists. That makes sense.
And then in the button styling, I was like, hey, this is the background color, this is the padding, this is how we want it rounded.
Awesome.
So we get our things. So that also means that now if you change this button styling, it changes, well.
So it's easier to change all the buttons in one place. So it is easier to give the different buttons different colors. No, it's this one. Indeed, this makes it easy to change both buttons.
Yeah.
Note that since we are working in a pure functional language, you are free to move everything into separate functions. We have changed our message type, but we have left our model alone. Let's change that. Add a second counter in a row so we can count two things. Cool. So we want to count two things now. So we can start off with, let's see, we got a column. And do we want to start off with just adding another thing here?
So what I would do is I would just make a row and put the column as the first element in that row.
Oh, we got a row. I see.
So instead of what you did just now, just treat the whole thing as a black box and then.
Oh, we need the.
You need the column thing before. still.
But those centers are going to move onto the row.
Yeah, and you did the weird thing with brackets.
We don't want that. Column.
Yeah, you have like two lists inside of each other for some reason.
Not valid. Because does this need to be treated as one thing?
Well, row takes a list of elements to put in a row.
But
and
column.
You currently just give column.
Oh, column. That's still a list. Oh, I see. I see.
So, yes.
Okay. And then we need another column.
Yeah.
Oops. Cool, but they're both going to increment, so now we need to separate them out. So we could do count 1 and count 2. How far do we want to go down the rabbit hole in this one? Count 2 things. Do we want to count 2 things separately?
You just want to count 2 things separately.
Yeah.
I highly recommend, since the reformatting is so easy in Elm, which you will see. Don't try to prematurely like generalize stuff. Just do exactly what you're doing right now.
Copy. Did we get it right? Oops. Because, aha, we tucked away our increment into the button. Whoops. So we need we need to get this out of there.
You could just make it an argument.
Yeah, we just make it an argument. So you can take it in, and we take what is the type that we want to pass in here. Well, we know increment is, what is this? Type message? A message.
I would call it message.
Int. Well, we might as well just like wrap this whole thing.
So before you take further steps, just try only to replace that thing that you just selected.
Just replace that.
Yeah, because you now, for some reason, also have removed amount from your thing. Don't.
Yeah, I was trying to. Okay, so we're at the amount. Well, to replace this, this needs to become one of our messages. And it's like an increment callback.
Yeah.
Okay. But then we also need amount to format it for the button. So that needs to stay there. Ah, but that just feels so strange. That doesn't seem right. The way that you solve this with putting the styling as a list is like, that's what I want. I don't want to deal with this. I want to go back. But then again, it's like we would have so many more buttons that we have to deal with.
Like what you're currently doing will work.
What I'm currently doing, well, I need this to be.
Well,
Oh,
what if you try just making that message,
yeah. What if we just
like,
did?
or call it,
Does this work?
and then replace increment by message? Because if you want to know if it works, just click compile, and it will tell you where it works or does not work.
The second element. Yeah, right. Increment. This increment value is an int message. We duplicate it. Feels a little strange, but I think that technically works now.
Yeah, you'll fix it soon enough.
Yeah.
I mean, this is a more difficult example where you're working with nested stuff, so you should be able to figure this out.
Yeah. Cool. The message value is not a function, but was given one argument. Because I'm calling this. Maybe.
You're calling it with
Yeah,
an
I
int.
don't know
So
why I had that.
the thing here, your type is wrong on line 40.
On line 40, because I need this to be int message. I see. Interesting. Increment 2. What's wrong with increment 2?
I see the problem.
You see the problem.
Okay. You need to spell it out, like say it out loud.
Yeah. So we have model, we have count 2, initial model, we're initializing them. Count is 0, count 2 is 1, increment. It takes an int.
Okay, so we start with count being 0 and count 2 being 1. What happens when I click the increment 2 with 5? What kind of message does it send?
Increment 2, that gets passed into there with 5.
Yes.
We go to our message model with our amount.
So that's, yeah.
And then we are updating model. So haha. Very good. There you go.
Yep.
Cool.
And this is one of those classic examples where having a type checker doesn't help you.
Doesn't help us.
Because what you typed was valid. Like, it had no way of knowing that that wasn't the behavior that you wanted.
Yeah, exactly. We were out on our own. Now I have 2 counters. Cool. Congratulations. You have 2 buttons. Your code should look. Let's see how you did this. Okay, same thing. Increment. Count 2. Count message. 1. Counter.
I did the same thing.
Am I blind? Where's counter being included? Oh, there. Okay, cool. Yeah. Awesome. Cool. And then, right. You just put that into its function because we know that this thing is like a counter. That's like the component we're dealing with. Cool. So I'm going to steal your code. We're going to edit off of yours now.
It's there.
Yeah. But it turns out the communication with the client was not ideal. Make, add, or subtract buttons for the number of counters there are. Hint, use a list. Ooh.
So we've now added one counter,
Yeah.
but we need to add like plus and minus button to change the number of counters.
Change the numbers of counters. This is interesting. I love how simple this is, but how it grows in such a nice way. Like it's like a counter of counters. I know, it's so nice. Ooh, okay, interesting.
I spent some like elbow grease on this.
Yeah.
Some exercises.
Yeah, this is a good one.
Because here you're gonna have to do some like you need to really think about like how am I even gonna model having an arbitrary amount of counters.
Right. So, well, model, we got to start with our model. And in our model, we want to have, what is the syntax for a list of ints? Do I just...
The word list.
List of ints.
I will help you with the syntax for list.
List of int, and this will be our...
Where is the...
Counters. Counters starts as an empty list. Is that right? Maybe we don't know yet. Cool. So also amount only has one M. That's okay. Increment our, so now we need to index our counter. Model at counters at index, perhaps. Elm index list. Array.
I'm gonna help you with some functions.
Yeah, we got some
to save you some time on
syntax.
Spending a lot of time looking at this. Also, I need to go some time in the near future.
Cool.
But I do have some solution that someone sent to me once. If I can only find it. Also, my foot is sleeping, which is getting annoying.
Your foot is sleeping?
Yeah. That's the wrong one.
List. We don't have direct indexing. However, you can use list.extra.getAt.
Yeah, no, I think that's the one that was used.
GetAt. That doesn't feel intuitive for something so common.
So that is to do with how lists work in Elm.
Range.
So, or in like any functional languages.
Yeah.
So the thing about a list is built of a first element followed by another list.
Mm-hmm.
Like that's how the data type of the list works. So if you want to get something at a certain position, you cannot for certain know that this index exists.
I think there's array.get. Would that work?
Yeah, but then you'd have to use an array instead, and you cannot use an array here because you don't know how long an array needs to be.
Oh, is array of static length?
Yes. List. So the thing is, if you say, hey, give me the second thing in my list, how do you know if the list has two things?
Yeah.
And more importantly, what do you do when you run out of list?
Yeah, right.
And the answer for JavaScript is crash, and we
I
don't do
see.
that in Elm.
We're being held accountable.
We're being safe. Being
We
held
love it. We love it. We just go with it. All right. So, okay, so our first step
You
here,
might need to explicitly import the list extra package.
yeah.
Which I don't remember how to do that.
We got ChatGPT helping us. List
And I'm
extra
gonna
exposing get at.
see if I remember the person who sent me the solution.
Okay, so increment IDX amount. We need to now access our model. To our model's counters at the index. So, and then I think we do case get at model IDX model dot counters of, and then it looks like we need to say if it's just a number or nothing.
I found the model solution that someone made.
Is it like,
which is
he using the get at?
Yes, they are. If I can, yeah, they are.
So just that.
And there is a nice thing in Elm where they like you need to deal with this just thing.
Yeah.
But there's also a function called maybe.withDefault. Which is basically saying, hey, whenever it's a nothing case, I'm going to just give you some default number. So in case you're, in this case where you're just sort of getting the number, you can...
What would the default be? Because we definitely want an error if we're trying to access a counter that doesn't exist. Or do we just...
Yeah, so if you have an error, you can do that.
Yeah.
But in this case, since you're never going to expose this to any form of user input,
yeah,
you can also be like, just increment the first counter instead if someone accidentally messes that up.
We're just going to go with that.
So you can...
But it might be
like,
it might be a length 0, so that might not be like possible. All right, do we just no? I mean, I want to do this. I want to do this right. Because I'm kind of like curious, like what is the right way? Like what feels right here? Because that feels a little weird.
I do have to go at half past.
Okay, that's fine.
So you got 10 minutes.
I think I can do this. Okay, so nothing. So if it's nothing, if we don't,
and I sent you the
counter,
model solution if you want to have a look yourself.
How do we just return? Like I don't care if it's nothing. If it's nothing, like I don't do anything. How do I like not do anything?
So you cannot do that.
I can't
because then
nothing.
The type.
Oh, I just returned model. I just returned model.
Yeah. That's also a thing.
Yeah.
You can just say like model.
Yeah, and then if we do have our count, okay. Let's see. How do we do this one? So, I need like list. I need to like set at, or do I now map over my counters, and then update?
I believe listed extra has a set at function. Actually, I am very certain
set at.
It has a set at.
Set at our thing, and then it. Cool. Sure. Okay, we have get at, and then counters is equal to set at our index amount list. Index amount. Uh-oh. Oh yeah, no, we know what that is. Amount, and then list model that counters, right? Maybe.
I mean, you can always hit compile and check.
Oh, we need to import list extra.
It's the package thing, and you just look for list extra.
There we go. Perfect. Increment.
So the only thing that I really find annoying about the packages is that there are some things that have the same name.
Yeah.
For legacy reasons, which is usually confusing. So you need to be a bit careful that you do not accidentally import the wrong package.
Yeah. Yeah, this is like a bit of the advantage of the approach that Go takes, where you're like absolutely referencing like a package via a URL.
But well, then like the combination username package name is still unique.
Yeah, I mean, it's like it's a full like oh right, in Elm it's you still have username package name. Yeah,
but you need to also take into account the username.
Yeah. Counter. Okay. Whoops, why did I delete that? Oh yeah, because we don't need that anymore. Okay, so now we need to go through each one of our counters. So we need to, this now becomes a map over model.counters. Map. Yeah, we can take a function list and return the list. So
and like this is getting kind of complicated at this point. I highly recommend if anyone's watching this to have a go at this yourself.
Yeah, this is really interesting. So you got model.counters, and then oh no, but we want to say map. Do we have list imported here? No. Exposing. I'll just import list. List.map is fine. List.map, and then we take a function, which maybe it just can be counter. Count message. Oh right.
Yeah.
Do we need to pass that in still? I guess so. Counter, okay, that's fine.
I think I might need to explain a tiny bit of convention here.
Yeah.
If you have a function, you put your that takes multiple arguments. You tend to put your what they refer to as your data argument last.
Data argument is last. Okay.
So the data argument is the argument that's going to change the most. So
isn't this so when you want to move this around, like int it more? It's
no, don't change the counter function. Okay. That's fine.
Whoops.
But in fact, like putting the actually swapping those around would be more conforming that convention.
Yeah. Because count's going to change, but counter message is going to stay the same because that's just a function.
Yeah.
But yeah, I see what you mean.
So that's in general something to keep in mind.
Mm-hmm.
And that's mostly useful in case you want to use the partial application where you want to use a map on some function.
Index map.
Because then you can easily give the first thing. But index map is also
that's what we want.
Fairly useful.
And does that actually just, I think that, well, this now becomes index and model that counters. What else are we? Oh, and then we're passing in the current amount. That becomes count. Let's see what we got. Cannot find count message variable. That's fine. Because
Yeah, you've renamed that to count.
Just increment. Increment IDX 1. Try adding that to see if it helps. That's funny. Yeah, where are we messing up here? We're on line 53.
Oh, the element on line 53 has no opening bracket for the styling.
There's no opening bracket for the styling. Oh.
Yeah.
Whoopsie. Do you have a close bracket format?
Oh no, it doesn't need that because it has a thing. Because now you're.
Is that colon, right?
Yeah, so the colon is the difference between adding one thing to a list or adding a list of things to a list.
Mm-hmm.
So if you make this plus, it will work.
Yeah. Okay. Second argument to row is not what I expect. But row needs the second argument to be list element message.
Yeah, brackets.
Brackets or parentheses?
Yeah, brackets.
Brackets.
Well, not square brackets because you're not giving in a list because the list.map already produces a list.
So, shouldn't it be parentheses then?
So it currently looks like you're giving row 4 arguments, and now it looks like you're giving row 2 arguments.
Yeah.
And that will be especially clear as soon as you click the format button.
Okay.
So that actually puts them under the...
The second argument to index map is not what I expect. The value at .counters is a list int, but indexed map needs the second argument to be list int to message. Oh yeah, right. Oh, okay. So now we need to be able to create a new counter. So we got row. How do we want to toss this in here?
And I would like to emphasize again that here it is a really think about these types and do not think so much about the actual implementation. Like, get the type checker happy first and then only check if you have any logic errors and such.
Right. Well, we have that. We have it happy because it didn't complain. But now we need to we could just start off with one counter. We just initialize this. Oop. Oh, yeah. Oh, but we still need to be able to add another one.
Yes, but you can. This is a nice test.
Yeah, that's sweet.
And that actually works.
That works. Look at that.
Good job.
That's cool. What is so cool is the feeling of you focus on this because it's you have in your head kind of what's going to happen here, and then you model it, model everything that happens, then everything else just kind of shakes out from there.
Yes, exactly.
Because then it's this just needs to exist now. How do we make that exist?
Yeah.
And now you don't have to think about this at all. You're just done. Once you figured it out, you're done.
Yeah. And the nice thing also is once you have this implemented, you can now look at the type of counter and know everything that you want to know about the function. You don't need to look at the implementation at all. Because you know exactly, oh, counter is a thing that I can give 2 inputs and it produces a message.
Yeah.
The biggest complaint I would have about your code right now is the complete and utter lack of comments.
We love comments.
Because
I'll just ask
it doesn't
ChatGPT.
really say what these integers do. One thing that might be nice, what you can do is you can make a type alias called index for int. So if you go at the top, or somewhere, you in the same way you have type alias model, you do type alias index.
Okay, and that's an int.
Yes.
Okay. Okay.
And then in your function, where you take an index, you replace int by index.
Oh wow.
And you could even take
so cool.
You could take this one step further.
Yeah.
Because right now, index and int are the same. So you've basically renamed an integer.
Yeah.
If you, instead of making it a type alias, you go back up. And you change it from type alias to just be alias. Or just be type, sorry.
Yeah.
So you remove the alias part. And then you need to add the word index in front of int. In the same way that we have...
In front of int. What do you mean by that?
Yeah, right there. Put index.
Oh, type index? Okay.
Yeah. And now press compile. It will tell you that, hey, this counter value is a index to an int. So if we go there.
54.
Give me 2 seconds. I need to answer a call real quick.
Cool.
Sorry. Had to... the guy who I had another appointment is here. I'm just going to finish this thing. So... Cool. The thing now is you have this index int. Yes. If you click compile, it will complain about line 54 where this counter is a thing. Yeah. So the problem here is that your counter is the value is it? But index map expects an int. Yeah. So the thing is your index map will give you a list of numbers. So we now need to explicitly convert the integer into an index. So to do that, we can put the counter function in brackets.
Counter function in brackets. All right.
No, like the sorry, parentheses. Okay. My mistake. Sorry.
Say index.
And then, yeah, so we do, and then it might be best to make it a lambda instead.
Lambda, is that like slash?
So what you do is instead you do like start, and then you say like int, and then you put a little arrow. And then this counter function. So we're going to remove index to the right of counter.
Oh, move it to the right of counter.
And let's do some defensive. Let's counter takes 1 argument.
Yeah.
Right now, which is
int.
So we put...
But we need a name for this. Do we give this a variable name? This int.
We don't use capital int, lowercase I.
Just I.
int, and then I is fine. And then in
And
here we put in brackets, we put
index I.
index int, index I, yeah.
Does that work?
And this should already work. Give that a go.
First argument. Oh, because now this get at expects an int. So we need to put it back to int.
It doesn't work like that. What we need to do is we need to put index there.
Index.
So instead of int, put index. So this now only will work if this index thing is an int.
Mm-hmm. Well, the problem is IDX is currently an index. But we need to now make it an int so that get at works.
Oh, sorry. In the increment, where IDX, that's where you put it in brackets. So put IDX up there in brackets. And say that IDX should be an index. So you put index there.
Ah, okay.
So what you're now saying is, hey, does this thing look like an index?
Yeah.
And by doing this, now you basically made it that you can only use an index if you explicitly convert into an index. So now you can no longer accidentally put an integer where you expect an index.
Can't put an integer where you expect yeah, right, because
so you can no longer call counter with like 5.
Yeah,
you need to call it with index 5. So this forces you to be very explicit about adding in this whole index thing, which can be really nice if you want to be sort of safe about this.
Yeah, I can imagine this can get really complicated.
So this index thing, it's a really dumb trick.
Mm-hmm.
And if you need to do anything else with indexes later, you'll see how you can sort of just use that with that constructor thing.
What is this saying? Like, can you break this down for me? Like, what is that?
Yeah, saying? So this is the same. This is equivalent to having saying, hey, message increment int that we have below, except here message and increment would be the same name. So we say we have a type called index. And we say, hey, we have a constructor for that type, which is also called index.
Okay, so is it like, are these two separate things or are these the same?
These are separate. Like the top one is the type and the bottom one is the way to make this thing. So you could change the bottom one to be like my index, for example.
And then what would that affect? So now this needs to become my index.
Yeah.
Increment becomes my index. Okay, I think that makes sense now. Because it's a constructor.
Exactly.
For that type. And
so in the types, you still say...
This is still the type. But when I'm moving from int to index, like that's how I construct an index.
Yeah.
Okay.
And in the case statement, you can also see that's how you can sort of look at this thing and basically unwrap it.
I see.
Inside of the case.
Because it's like I'm looking for things that follow this pattern. It now can unpack because it knows, oh, index must be an int because I'm doing that. But if I were to, I can make another constructor here with like my index float, and this would be a problem now because now it can't tell if that's an int or a float.
Well, you can compile this and see what happens.
Do I need my index too?
Oh yeah, they can be the same.
Now we're not. Oh, I see. It would be just.
Then they say, "Hey, you're missing a possibility."
So now you would need to make a whole
add a special
one.
Case for,
okay.
Or change the thing back again.
Yeah.
But having a float as an index is kind of weird. But
yeah, it doesn't make sense. But like, this is how I'd handle it. Like, I would have to explicitly say like, I handle when
Precisely.
it's a whole nother type, because it is a whole nother type.
Yeah.
I
But
see.
I'm afraid I'm gonna have to leave you
Yeah,
here.
that's fine. That's fine.
Because I have.
This is very
But you
cool.
can continue doing that. One more thing, which might be nice, is I can sort of shortly introduce the next exercise.
Yeah.
So this is really a like knowing this and being able to do this allows you to do basically whenever, because you can just add styling and abstract from this and work from this. If you scroll up to the top, because like this exercise sort of speaks for itself.
Mm-hmm.
You have this advent of code thing. So have you ever heard of the advent of code?
Yeah, I've done that before.
Yeah. So there's some problems with this, and someone has made a playlist on YouTube solving these advent of code things, and I made a Elm template that will which you can open with the link there, where you can, if you scroll to the bottom, you can basically ignore all this model stuff and just work with an input and answer thing.
Very cool.
Which is basically a template where you can play with advent of code problems.
Awesome. That's pretty cool.
And this helped me a lot because the person doing these videos is more experienced in like, oh, these are useful library functions, because I was implementing all this stuff myself and I was like, oh, this just exists.
Yeah.
So if you want to be a bit more comfortable on the logic side and like how do you wrap things, unwrap things, deal with tuples, deal with lists, then I can highly recommend that part of the exercises.
That's cool. That's cool that someone did that.
And then that's about it. So
cool.
Good luck with the rest of this exercise. I hope you will find the last exercise funny.
I want to be a counting god.
You can click the button and see already.
Cool.
So the last one is like, oh, you now have one row of counters. We want to make n rows of counters.
That's cool.
So you can fill your screen with counters of different like number of counts.
That's such a good example because it's you should go. You should go if you need to go.
Yeah.
But this is awesome. Thank you so much. This is really cool.
Yeah. Speak to you again sometime.
Yeah, we'll figure out the next topic. Bye. All right. Well, I think this concludes the stream because I need to go to the bathroom. But yep, there you go. There is Elm. I'm so stoked. This is such a cool language. I love type systems. Anyway, bye.